It is, it's funny how we often glorify the whole Rube Goldberg machine concept.
Oh, absolutely.
Like you see those videos online, right? Where a marble rolls down a track and then it hits a domino, which triggers a fan.
Yeah, and the fan blows a little toy boat across a tub of water.
Exactly. And all of that just to ultimately, I don't know, flip a light switch.
Right. I mean, it is totally mesmerizing to watch. It's undeniably clever.
It is. But if you actually just want to turn on the lights in your kitchen at midnight, you don't really want a labyrinth of dominoes and pulleys. You just want a simple switch.
You definitely do.
Well, welcome to the Deep Dive. We are so glad you are here with us today. Our mission is to explore a highly specific, totally fascinating developer journal entry from July 9, 2026.
Yeah, this entry is by an author named Ang, and it's titled Notes-on-Haskell-Programming, Part 182.
And while we are going to be looking at a few lines of Haskell code, this is really a universal story. It's about that exact tension we were just talking about.
Yeah.
The battle between being clever with your problem solving and just having simple human readability.
It really is a phenomenal artifact. It captures this very specific moment of realization for the author.
Because Haskell, for those who might not spend their weekends reading programming documentation, it's a strictly functional programming language.
Right. It is heavily rooted in academic computer science and mathematical rigor. The community around it really tends to value code that is elegant, abstract, and highly generalized.
Right. So when we look at Eng's notes here, we're essentially observing a developer working inside a culture that actively encourages building intellectual Rube Goldberg machines.
Exactly. And then suddenly deciding to tear one down.
Okay, let's unpack this.
Mm,
Because the specific problem Eng is tackling is fascinating on its own.
it really is.
The journal entry centers on a code refactoring for a function with a very descriptive no-nonsense name. It's called single width to double width.
Right. It does exactly what it says on the tin.
And the source text shows us some highly specific character mappings this function is handling. Like, it takes standard quotation marks, the hex code in the text is /by201c, and turns them into a different hex code, /by300c.
Yeah, those hex codes are basically the universal digital fingerprints for characters. Deep inside your computer's memory, it doesn't actually know what a quotation mark is.
It only knows numerical values.
Exactly. So that hex code tells the rendering engine exactly which specific shape to draw on your screen.
Right.
There is absolutely zero ambiguity.
Right. And it's not just quotation marks. It also targets a standard keyboard space, just your normal blank space, and converts it into what Eng explicitly notes is an ideographic space, or a full-width CJK space, which is /by3000.
Oh, and it goes way beyond just spaces and quotes, too.
Yeah, the text shows it applies to a whole continuous range of characters. It expresses it as an exclamation mark up to a tilde.
Which is pretty much the entire ASCII punctuation range. That effectively covers every standard visible punctuation mark and symbol you'd find on a traditional English keyboard.
Okay, now I do have to push back here for a second, or at least ask for some conceptual clarity.
Sure, go for it.
When the text says full width and double width, my immediate instinct is to picture like a visual distortion.
Oh, I see what you mean.
Yeah, I imagine taking a standard letter A, grabbing the corner of the bounding box in Photoshop and just dragging it horizontally so it stretches out like a terrible image resize. Is that all this function is doing? Just stretching the font?
That is a really common misconception. What's fascinating here is that the issue is actually fundamentally structural, not just visual.
Structural how?
Well, CJK stands for Chinese, Japanese, and Korean. And the typographical traditions for these languages evolved very differently from Western languages.
Okay.
In standard Western typography, we rely on proportional spacing. So the letter I is physically narrow, right? It takes up very little horizontal room on a line.
Right, whereas a W or an M is super wide.
Exactly. The text flows fluidly from left to right based on the specific width of each individual letter.
Which makes perfect sense for an alphabet.
But traditional CJK text is historically laid out on a rigid two-dimensional grid. Every single character, ideally, occupies a uniform, perfectly square box.
Oh, wow. So the spacing is actually implicit in the grid itself.
Precisely. So when you introduce Western punctuation, like a standard proportional exclamation mark, or a tiny standard spacebar space into a dense block of Japanese or Chinese text, it entirely fractures the structural integrity of that grid.
Ah, I get it now. The Western characters probably look minuscule and squished.
Yeah, they look totally misaligned compared to the complex square ideograms surrounding them.
Oh, I see. So it's less about stretching a font and more like trying to force a skinny rectangular Lego brick into a perfectly square slot on the base plate.
That's a great analogy.
It just leaves these awkward, unbalanced gaps on either side that ruin the pattern.
That is a much more accurate way to model it. A full-width character isn't a stretched character. It is a distinct, specially designed version of a Western character, crafted by typographers to sit perfectly centered within that larger, square CJK grid box.
So by systematically targeting that exact ASCII range, the exclamation mark to the tilde-ang's code is basically hunting down every single skinny Lego brick in a string of text.
Right, and swapping it out for its designated square, full-width equivalent.
Okay, so if this translation is essentially just a matter of swapping skinny Lego bricks for square ones, which sounds like a fairly basic substitution, why did Aang's original code cause so much mental friction?
Well, that's the real core of this journal entry.
Because the text makes it very clear that Aang had already written a version of this function that worked perfectly, yet felt compelled to go back and completely rewrite it.
This raises an important question about the hidden costs of software architecture, specifically something called cognitive load.
Cognitive load, okay?
Yeah. If we analyze the diff in the source text, the direct comparison showing the old code being removed and the new code being added, we see Aang initially utilized a two-step approach.
Right, I have the diff right here. First, the code defines something called raw pairs.
Exactly.
And looking at the source, raw pairs seems to be just a raw list of the before and after characters. The skinny brick paired with the square brick, written out as basic text strings.
And then comes the second step.
Yeah.
Which is where the functional programming mindset really reveals itself.
Uh-oh.
Aang applied a sweeping transformation function over that raw data. The specific line in the text is map bimap t.pack raw pairs.
Okay, wait, let me see if I can interpret the mechanics of this.
Yeah.
Because it honestly sounds like a classic software design pattern.
It absolutely is.
In computer science, separating your concerns is usually taught as the golden rule, right? So Aang isolates the data, the raw pairs, from the action being performed on that data.
Spot on.
The text shows Aang importing a library called data.bifunctor. Now, bifunctor sounds intensely mathematical, but just breaking down the prefix, I assume bimap is a tool that lets you map an action across two things simultaneously.
You nailed it.
Okay, so the code uses bimap to apply a packaging function, t.back, to the left side of the raw pair and independently to the right side of the raw pair.
Yes, exactly.
It feels very modular. You build your raw materials over here, and then you build a completely separate processing factory to handle them over there.
Yeah.
Why fix what isn't broken?
Your interpretation of the mechanics is flawless, and you've highlighted exactly why this approach is so seductive to developers.
Because clean.
It is mathematically pure. It abstracts the operation entirely away from the data. But let's evaluate this from the perspective of human psychology and working memory.
Okay, let's do it.
Imagine you are a developer reading this code 6 months from now. Your eyes hit the single width to double width function. The first thing you encounter is map by map, t.pack, p.pack.
Okay, so I immediately know a continuous transformation is happening. I know the factory machinery is turning on.
Mm-hmm.
But I haven't actually seen the raw materials yet.
Which means your brain has to temporarily store that abstract factory machinery in your mental RAM. Yeah. You are now holding on to the concept of a dual-sided packaging operation.
Right. I'm juggling that thought.
Then your eyes have to physically scan down the screen to locate where raw pairs is actually defined.
Oh.
You find the list of raw strings, like the standard space and the /3000 full-width space. But to understand the actual final product that the software is going to output, your brain has to manually combine the machinery you stored in your mental RAM with the raw strings you are currently looking at.
Wow. So I have to mentally hold the assembly line in one hand, the raw materials in the other, and simulate the manufacturing process in my own head just to figure out what the data actually looks like.
Precisely.
I'm essentially acting as the compiler.
You are. You are forcing the reader to synthesize two disconnected abstract concepts. It might only take half a second of mental effort to parse that line.
But in a code base with thousands of lines, that adds up.
Exactly. Forcing the reader to constantly simulate abstract mathematical transformations leads to massive cognitive fatigue.
So it's clever, but exhausting.
Haskell developers love bimap because it's a generalized, powerful tool. It feels incredibly clever to write. But Aang realized that this cleverness was actively hostile to the person trying to read it later.
Here's where it gets really interesting, because Aang's solution to this cognitive fatigue is to just tear down the factory completely.
Yep, total demolition.
Aang throws out the data.byfunctor library. The bimap tool is completely erased from the diff. Instead of that two-step modular approach, Aang shifts to a one-step approach using tuples.
Right.
Now, before we look at the syntax, how does a tuple fundamentally change the way the computer and the programmer treats this data?
Well, a tuple is one of the most foundational data structures in programming. While a standard list can hold an infinite number of items and is usually processed sequentially, a tuple is a finite ordered pairing of elements grouped closely together in memory.
Okay, so it's a package deal.
Exactly. It isn't an abstract mathematical operation waiting to happen. It is a concrete physical pairing. By abandoning bimap and moving to tuples, Aang is deciding to format the data exactly as it needs to be used, right at the moment of creation.
Okay, I have another analogy for this.
I love your analogies. Let's hear it.
It's kind of like packing a suitcase. The old way, the bimap way, was taking all your clothes out of the closet, laying them out flat on the bed, and then doing a second, completely separate pass to fold and pack them into the suitcase.
Oh, that's really good. Yeah.
It's 2 steps. But this new approach, it's more like taking the clothes off the hanger and packing them straight into the suitcase in one fluid motion.
That is exactly what is happening here.
We can see this in the exact syntax Aang uses for that massive range of standard characters we mentioned earlier. The list comprehension in the text reads, open bracket, tuple, open parenthesis, t.pack comma, t.pack to enum from NMC plus full width offset. Wait, I'm just reading code now, but you get the idea.
I do. That line might look totally dense to a layperson listening, but structurally, it is a masterpiece of clarity compared to the old version. Let's look at where the packaging command t.pack is situated now.
It's literally right inside the parentheses of the tuple itself. It says t.pack, and then the next item is t.pack.
Right.
The command to package the character is physically wrapped around the character at the exact moment it's being defined.
Notice how the physical visual layout of the code on the screen now perfectly mirrors the resulting data structure in the computer's memory.
They are completely intertwined.
The definition and the transformation are basically hugging each other. The reader no longer has to scan down the page to find the raw data, nor do they have to hold an abstract bimap function in their working memory to simulate the outcome.
The mental middleman is entirely eliminated. It's like a 3D printer just outputting the finished object. You look at the code and what you see is exactly what you get.
Aang's own commentary in the journal entry summarizes this epiphany beautifully, actually.
What'd they say?
The author writes, "This reduces complexity and improves readability as we can see the resulting structure immediately."
See.
As we can see it.
Exactly. The critical word in that sentence is see. Aang prioritized visual immediacy over abstract mathematical purity.
So what does this all mean? Because we spent a lot of time zooming in on hex codes and CJK typographical grids and the mechanics of tuples versus bifunctors. But zooming out, what does this microscopic change in a sea of software tell us about the broader life cycle of mastering a complex skill?
If we connect this to the bigger picture, we really have to consider the metadata of the source text itself.
Right, the title.
Yes, this entry is explicitly titled Notes on Haskell-Programming, Part 182.
Part 182. I mean, that implies a staggering volume of previous trial, error, late nights, and documentation.
Absolutely. This isn't someone on day 3 of a coding bootcamp.
No, definitely not.
It implies a long, arduous, and highly intentional journey toward mastery. And consider the context of this specific refactor. The original code functioned perfectly.
It worked. It compiled. It performed the CJK width conversion exactly as required by the system. A junior developer, or honestly just someone trying to close a ticket by 5 p.m. so they could go home, would have left the bimap implementation alone and moved on.
Yeah, because the machine was perfectly happy with the original code.
Right. The computer doesn't care about cognitive load. It doesn't get mentally fatigued. It just executes the math.
But Aang went back anyway.
Aang went back.
Yeah.
Aang spent valuable time and mental energy to rewrite perfectly working code. Not to make it run faster for the machine, but to make it read smoother for the human.
That is dedication.
We also see this deep intentionality in the curation of the tools mentioned in the text. Aang explicitly lists the imports. data.char, data.set, data.text.lazy.
Right, curating the toolbox.
Managing these imports, making the conscious decision to rip out the data.byfunctor library because the bimap tool it provided was causing unnecessary abstraction. That is the behavior of someone tending to their code base like a meticulously maintained garden.
Pruning away the cleverness.
Exactly.
It really makes me wonder about the trap of expertise, like when you are learning a complex system, whether it's functional programming or law or engineering, there's this phase where you acquire all these incredibly powerful, shiny new tools.
Oh, the shiny tool syndrome.
Yeah, you learn about things like bifunctors, and suddenly every single problem looks like an opportunity to showcase your sophisticated new hammer.
It is a very well-documented phenomenon. In the software industry, it's frequently labeled over-engineering.
Okay, yeah.
When you are at part 20 or part 30 of your learning journey, your primary adversary is the compiler. Your entire focus is just forcing the machine to understand your commands.
You write code just to prove to yourself that you can make it work.
Right. But as you cross the threshold into part 100, or in this case, part 182, your awareness shifts.
The audience changes.
Exactly. The realization hits that writing code for a machine is actually the easy part. The machine is flawlessly logical. The true challenge is writing code for the fragile, easily fatigued human mind that will inevitably have to maintain that system a year from now.
That is such a profound shift in perspective.
True mastery isn't about juggling a dozen abstract concepts to prove your intellectual bandwidth. It's about structuring your work so clearly that no juggling is required by anyone.
It is taking the elaborate, mesmerizing Rube Goldberg machine, dismantling it piece by piece, and having the confidence to just install a plain, obvious light switch on the wall.
I couldn't have said it better myself.
To bring this all together for you listening, we started by examining a highly specific typographical challenge. We looked at building a bridge to allow standard, skinny Western punctuation to sit harmoniously inside the rigid, square grids of traditional Chinese, Japanese, and Korean layouts.
Right. And we saw how a developer initially approached this translation using a two-step assembly line, basically isolating the raw data from a clever mathematical mapper called bimap.
But we discovered that the allure of that modular cleverness was actually a trap. It forced the future reader to act as a human compiler, storing abstract functions in their working memory and mentally simulating the data transformation.
So in the pursuit of genuine readability, the developer threw out the clever tools.
They did. They merged the data and the transformation into a single, unified tuple, ensuring that the physical layout of the code visually matched the final data structure.
They sacrificed mathematical abstraction for visual clarity.
And that quiet, deliberate act, tucked away in the 182nd chapter of a personal journal, beautifully illustrates the profound shift from writing to instruct a machine to writing to communicate with a fellow human being.
It really reinforces the reality that in any technical discipline, empathy and clarity are far more difficult to achieve than raw complexity.
They really are. Empathy is hard work. Now, before we sign off today, I want to leave you with one final lingering thought.
Oh, I love these.
It relies on a specific piece of syntax from the text that we briefly mentioned, but we didn't really dissect. It's the logic that handles the actual conversion for that vast range of ASCII characters.
Oh, right. The to-enum from enum logic.
Yeah, it reads, to enum from enum C plus full width offset.
Ah, the integer conversion logic. It's a brilliant little mechanism.
Think about what this is actually executing under the hood. To achieve this complex cultural, typographic, shift-moving assemble from the proportional traditions of the West to the grid-based traditions of the East, the code doesn't do anything inherently linguistic.
Not at all.
It simply takes a character and converts it into a raw number using from enum. Then it applies a static mathematical offset.
Just basic elementary school addition.
Exactly. And finally, it converts that new sum back into a character using to enum.
It literally reduces the entire history of typography down to simple arithmetic.
And it really makes you wonder, as we navigate our increasingly digital lives, how much of our complex human language, our intricate formatting, the millions of emotionally charged words we hurl across the internet every single day,
Yeah.
how much of it is ultimately just basic addition and subtraction disguised as culture, just silent numbers, shifting offsets behind the screen, creating the illusion of a shared language.
That is a wild thought.
It is definitely something to ponder the next time you hit the spacebar.
Thank you so much for joining us on this deep dive. We will catch you next time.